Welcome to the intersection of technology, cybersecurity, and society. Welcome to ITSP Magazine. You're listening to a new episode of Stories from Space podcast, where your host, Matthew Williams, examines the history of human spaceflight, the breakthroughs that revolutionized our understanding of the universe and our place in it, and the brave individuals who work tirelessly to advance the frontiers of our understanding. Knowledge is power, now more than ever.
The authors acknowledge that this podcast was recorded on the traditional, unceded lands of the Lekwungen peoples. Hello, and welcome back to Stories from Space. I'm your host, Matt Williams, and today I want to carry on in our ongoing series about settling the solar system, aka the Great Migration. In previous episodes, we looked at how human beings may one day live on the Moon, on Mars, in the clouds above Venus, on scorching Mercury, and in the main asteroid belt. Well, today, we'll be looking at how human beings may someday call the Jovian moons, the large icy moons that orbit Jupiter, a new home for humanity in the outer solar system. We're also going to look at how settlements on these moons could enable all kinds of cutting-edge research, how the local resource space could be used to create habitats that withstand the tough conditions, provide novel solutions for living, and how harnessing the resources of the Jovian system could usher in an era of post-scarcity economics and exponential growth for humanity, and how habitats in the system could serve as an outpost or stopover point for further expansion into the outer solar system. And of course, we're going to look at what the particular challenges of this are and what would need to happen before any such missions and endeavors could really be contemplated. Suffice it to say, this is a relatively far-off prospect, but interest in the Jovian system, interest in studying Jupiter's largest moons, it has been on the rise for many years now, thanks to a number of proposed missions, which will be leaving Earth in the not-too-distant future. And with the renewed interest in space exploration, with talk of establishing a permanent human outpost on the Moon, sending crewed missions to Mars and building a habitat there, plans and proposals that were suggested during the early space race are now being dusted off and reconsidered, and a lot of new insight and thought are being put into this. So to break it down, what we know about Jupiter's largest satellites, and these are Io, Europa, Ganymede, and Callisto, they're the only satellites orbiting Jupiter that were large and massive enough to achieve hydrostatic equilibrium, i.e. become spherical, and they are collectively referred to as the Galileans in honor of Galileo Galilei, who was the first to make any recorded observations of them. And this happened in 1610 when Galileo, using a telescope of his own design and manufacture, began observing Jupiter. And he noticed what appeared to be stars surrounding Jupiter. And these bright objects, he noticed, looking at them night after night, they appeared to be moving relative to Jupiter. And on one particular night, when he realized that one of them had disappeared behind Jupiter, he had a eureka moment and realized they were, in fact, natural satellites. And this was a major find at the time because, among many other observations that Galileo would describe in his treatise Starry Messenger, or Sidereus Nuncius, the discovery that other bodies in the solar system had satellites of their own and not just Earth, it demonstrated yet again that the cosmos wasn't perfect. As Christian dogma and the predominant models of astronomy at the time, Aristotelian and Ptolemaic, everything that came before Copernicus's heliocentric model, they all treated the cosmos as perfect crystalline spheres, the heavens, differentiated from Earth, which was matter and which was base. And much like his observation of sunspots or craters on the Moon, he demonstrated that that dogmatic item was false. And it helped him argue the heliocentric model of the universe and usher in the so-called Copernican principle, which said that Earth is not special, Earth is not in a unique and advantaged position to observe the cosmos. The cosmos is characterized by sameness. In any case, what we came to learn about these moons over time, it advanced considerably, mainly with the advent of modern telescopes in the 19th century, and then, of course, the explosion in space exploration by the latter half of the 20th century. And this includes the fact that these moons are predominantly composed of ice and volatiles with silicate minerals and metals concentrated in their cores. Of these four satellites, Io is the closest to Jupiter. It's slightly larger than our moon, and like all the Galilean moons, it takes its name from a consort of Zeus in Greek mythology. Zeus being the Greek equivalent to the Roman Jupiter, and so all the satellites are named after characters in Greco-Roman mythology. So accordingly, Io was named after the priestess of Hera in Greek mythology, who Zeus courted and cavorted with. And the moon itself is unique among the others in that it is the only one that's primarily composed of silicate rock and metal, and has the highest density of any known satellite in the solar system. And whereas the others are differentiated between a water and volatile crust and mantle, Io is composed of silicate crust and mantle, a molten lava interior, and a solid core made of iron and iron sulfide. And it is also one of the most geologically active objects, with over 400 active volcanoes on its surface, 100 mountains, many of which are taller than the tallest mountains here on Earth, and lava plumes that can reach up to 500 kilometers, or 300 miles, into space. Now, this extreme activity is due to tidal flexing in the interior, where Io is orbiting Jupiter, which has a tremendous gravitational pull. And as it orbits around the gas giant, this causes its interior to flex and stretch and contract. And this keeps things in a very energetic and molten state and powers that incredible volcanism. And Io also has a tenuous atmosphere because of all these volcanic eruptions, and it's composed predictably of your typical volcanic gases. And because it orbits so close to Jupiter, it's also smack dab in Jupiter's powerful magnetosphere, and this volcanic atmosphere of it is constantly being hit by charged particles from Jupiter, and this causes the planet to experience aurorae, much like Earth. Next in line, you have Europa, which was named after the Phoenician noblewoman and the daughter of the king of Tyre, who became a lover to Zeus and the queen of Crete. Europa is slightly smaller than Earth's moon and is only 65% as massive, and this is mainly due to the fact that Europa is predominantly composed of ice. And in terms of its structure, it has a silicate rocky interior with a possible iron core, then a layer of ocean, which is up to 100 kilometers or 62 miles deep. And its outermost layer consists of a frozen upper crust and a warmer liquid ocean beneath that. Based on various lines of evidence, this interior ocean is believed to be salty, to contain organic molecules, and likely to be oxygenated and heated by a geologically active core. And there are multiple lines of evidence supporting this, as I've said, which include plume activity on the surface that have been observed many times, and its smooth features, which indicate resurfacing events, where liquid from the interior bursts forth onto the surface, refreezes, and appears younger and smoother than older patches of surface that are cratered and show more prolonged exposure to space and solar radiation. And ever since the Voyager probes flew through the system in 1979, scientists have speculated that Europa may, in fact, harbor life in its interior ocean, which could be simple single-celled microbes or something more complex like aquatic creatures. And hence why there are multiple missions destined for Europa in the coming years. We want to learn more about its interior environment and whether or not it could, in fact, be inhabited. And then you have Ganymede, who's named after the young boy who was carried to Olympus by Zeus and became a cupbearer of the gods. Ganymede is the largest moon in the solar system. It's even larger than Mercury, although significantly less dense because of its water content, which is considerable. It is composed of equal parts water, ice, and silicate rock, in fact, with a solid inner core believed to be composed of liquid iron and iron sulfide, and a solid inner core And because of this, it is the only satellite known to have a magnetic field. Similar to Earth, the combination of a solid inner core and liquid outer core, which are counter-rotating compared to its rotation on its axis, this creates a dynamo effect in the interior, which powers a planetary magnetic field. And much like Europa, it is believed to have a deep ocean between two separate layers of ice. This would include the icy crust, but also a layer of water ice that basically, due to pressure and compression, has solidified around the core mantle boundary, so around the rockier and metallic interior. Ganymede also experiences auroras, which is believed to be the result of Jupiter's magnetic field interacting with the satellite's saltwater ocean. And it too shows evidence of cryovolcanism and resurfacing events in that it's got smooth surfaces and youthful-looking terrain that is sitting next to older, darker patches of surface. And last, rounding out the four, is Callisto, which was named for a nymph associated with Artemis, the goddess of the hunt. This is the third largest satellite in the solar system. It's about 99% the size of Mercury, but again is significantly less dense. And because of its distant orbit to Jupiter, it has never experienced tidal heating, which is made evident by its internal structure, which again is based on planetary modeling, which has had a significant impact on its internal structure and its evolution. The moon itself is about equal parts rocky material and water ice, with the addition of volatile elements that are frozen, like ammonia. And so, while it has an ocean too, or is believed to have a salty ocean, its core consists of compressed rocks and ices and a smaller silicate core, and the possibility of this interior ocean being warm and energetic are lower, but it is believed that with sufficient ammonia, which has a much lower freezing point, and heat provided by the decay of radioactive elements, it could still have a liquid water ocean. And unlike its peers, Callisto's surface doesn't show signs of resurfacing or cryovolcanism because it is saturated by ancient craters, with newer ones formed over older ones, some of which are particularly big. Now, what we've really come to understand about this system has really only been in the past few decades, thanks to robotic explorers. And this includes the Pioneer 10 and 11 missions launched by NASA, which flew through the system in 1973 and 1974, respectively, and took the first up-close pictures of the Jovian satellites. And these were followed up in 1979 by the Voyager 1 and 2 probes, who buzzed through the system and took more detailed images as they were making their way to the outer solar system. Then there was the joint European Space Agency and NASA mission called Ulysses, a robotic space probe that flew past Jupiter in 1992 and again in 2004, whose main mission was to orbit the Sun and study it from various latitudes. And like many spacecraft, Ulysses was relying on Jupiter to provide a gravitational assist maneuver in both cases, but used the opportunity to take more pictures and gather more data on the system. And the Cassini probe went by there too in 2000 on its way to Saturn, followed by the New Horizons probe in 2007. And to date, the only missions that have gone to the Jupiter system and stayed there, that have orbited the gas giant in order to provide more insight into the planet, its systems and moons, these were the Galileo mission, which reached the system in 1995 and studied the planet until 2003, and the more recent Juno mission, which arrived in 2016 and continues to study Jupiter to this day, and whose mission has been extended until September 2025. Now, while the Pioneer missions did provide some tantalizing hints about what might be going on in Jupiter's moons, it was Voyager 1 and 2 that provided the first real indications that Europa, that it might have an ocean beneath its icy surface. And combined with an understanding that tidal flexing in the interior was likely causing heat and hydrothermal activity, similar to what we see on Earth, where vents form in the ocean floor and volcanic heat is pushed up, as well as all kinds of chemicals that are essential to life. This began to fuel the notion that, in fact, Europa may harbor life underneath its icy surface. And this is bolstered by the fact that scientists believe that this may be how life began on Earth, that it formed around hydrothermal vents billions of years ago, which is backed up by fossilized evidence that says that fossilized bacteria, they remain the oldest life forms we've ever found on Earth, and they're to be found on the ocean floor. And since that time, scientists have observed similar evidence and activity on Ganymede, possibly Callisto, and many other icy worlds in the outer solar system, which they've come to refer to as ocean worlds. And as we addressed in a previous episode, episode 40, Signs of Life, What are Ocean Worlds, which are typically satellites that orbit much larger bodies that have just the right combination of elements of heat and energy or antifreeze, such as ammonia. Bodies like these, which are located in our outer solar system, these may be a place where life could exist in abundance. And it may even be the same for exoplanet systems, that the most likely place to find life is beneath the icy sheets of moons that have warm water interiors. And in the coming years, NASA and the European Space Agency, they plan to send multiple missions to explore Europa, Ganymede, and other satellites in the outer solar system, like Titan and Enceladus, to learn more about the possibility of life emerging there. And this includes NASA's Europa Clipper and the ESA's Jupiter Icy Moons Explorer, or JUICE missions, which are scheduled to launch sometime in this decade and reach the Jupiter system by the 2030s. If all goes well, NASA is also hoping to follow up on the Europa Clipper and JUICE missions with a Europa lander. And the purpose of this mission will be to actually touch down on the surface of Europa, scan its surface, and check out those water plumes in the hopes of seeing if anything organic or any biosignatures are coming out from the ocean beneath the icy surface. So, as you can probably tell from these descriptions, these mission proposals, the Jovian moons are a very, very tempting destination there for robotic missions, for science, for exploration, and at some point, space agencies around the world and nonprofits, they want to send crewed missions there to explore them more fully. And the main purpose of these missions are astrobiological in nature, to see if there is, in fact, life on these frozen planets well beyond the frost line, beyond what we consider to be the habitable zone of our solar system. And if, in fact, there is life there, it would have tremendous implications, not just for the search of life here at home, but for the search for life in other star systems. In fact, there's even a school of thought, which we dealt with in a previous episode, called the Ocean Worlds Hypothesis, that speculates that perhaps the best place to find life in the universe is not on terrestrial planets that orbit closer to their suns, much like Earth does, but on icy worlds that are in the outer solar system, that have internal heating due to tidal flexing. However, there have also been multiple proposals, since the dawn of the space age really, for establishing permanent settlements on these moons. And like all similar prospects and ideas, it has also been explored rather extensively in science fiction. And to give you some examples, one of the earliest was in 1953 by Robert A. Heinlein. His book Farmer in the Sky depicts a teenage boy and his family moving to Ganymede, which they are in the process of terraforming in order to make it an abundant source of crops for Earth. And the idea of a settlement on Ganymede is something that Heinlein would come back to in many subsequent stories. Paul Anderson, the author of Tau Zero, one of the most famous and influential books on the subject of interstellar travel, he also released a book in 1954 called The Snows of Ganymede. And in this story, again, the subject of terraforming comes up, but it involves a group of terraformers who are visiting a settlement that had been established centuries earlier by religious fanatics from Earth. And then you have Arthur C. Clarke's Space Odyssey series, perhaps the most well-known, in which Europa plays a very central role, mainly because of the speculation that was really quite common at the time. Now, in 2001, this subject really didn't come up. Jupiter's system of moons was where the larger monolith was residing and sending communications to the outside world. But for 2010, which Clarke released in 1982, and this was known as Odyssey 2, but the film adaptation that came out a few years later, it was known as The Year We Make Contact. The focus now is on Europa and how the monoliths may be attempting to encourage evolution there as well. I won't tell you how because that would spoil the story. And he would come back to that in Odyssey 3 and 3001, The Final Odyssey, which was the last of the Space Odyssey series that he wrote before passing away. And the idea of settlements on Jupiter's moons, that comes up in other authors' works, Philip K. Dick, Bruce Sterling, Alistair Reynolds, and multiple books by Kim Stanley Robinson, and that includes Galileo's Dream, which is appropriately named because, of course, it talks about the Galilean moons and involves a time travel angle. And there's also mentions of settlements in 2312 and his earlier works, The Memory of Whiteness and Blue Mars. And in his famous book, Accelerando, Charles Strauss spoke of how human beings may migrate away from Earth someday to escape the technological singularity and the conversion of the inner solar system into a giant matryoshka brain, this massive cloud of computronium that surrounds the sun. How these individuals would flee to the outer solar system and establish settlements on Jupiter's moons, as well as floating cities in orbit around the gas giant, and live out their days with all kinds of advanced technology and trying to stay one step ahead of the growing matryoshka brain, which was expanding outwards and consuming more planets. Getting to the scientific proposals that have been made, they are somewhat more recent, as is often the case with proposals for space exploration, space settlement, anything truly ambitious and futuristic there. It's generally the case that science fiction will predate scientific inquiry. And this is certainly the case when it comes to the potential for settling on Jupiter's largest moons. And many of these were, in fact, inspired by the Voyager probes passing through the system in 1979. And this included the private spaceflight venture known as the Artemis Project. Not to be confused with today's Artemis program to send astronauts back to the moon. However, this venture did begin in 1994 with a proposal to establish a lunar settlement by the 21st century. Nevertheless, 3 years later, they drafted plans to also settle on Europa. And their description of how this could be done, they advocated that igloos would be established on the surface, which would serve as a base for scientists who would then drill into the icy crust, explore the subsurface environment, and establish settlements within the air pockets in Europa's ice sheet. Because whereas Europa, Ganymede, and Callisto are all known to have icy surfaces, scientists have speculated that there are, in fact, these pockets of air within Europa's ice sheet where water can often percolate, but which may, in fact, be better places to establish an outpost or settlement because of the improved radiation protection. In 2003, NASA weighed in with a study called Revolutionary Concepts for Human Outer Planet Exploration, which otherwise went by the acronym of HOPE. And this addressed future explorations of the solar system and included a plan for sending human missions to Callisto. And these missions would begin in 2045, according to the proposal, and would consist of a base being established on the surface of Callisto, where science teams would teleoperate robotic missions to the other moons, and that would include a robotic submarine that would explore Europa's interior ocean and harvest water ice and use that to create rocket fuel and breathable air, and essentially act as a resupply base for further missions into the system. And according to this proposal, NASA said at the time that crewed missions to Callisto, they could be possible by the 2040s, provided that NASA could create a spacecraft that utilized nuclear electric propulsion and had a rotating section in order to simulate artificial gravity, in which case they could perform a 5-year mission to Callisto that would result in the creation of a base. And similarly, Robert Zubrin, the famed author of The Case for Mars and the Mars Direct report to NASA, he released a book in 1999 called Entering Space, Creating a Spacefaring Civilization. And he indicated that if in fact we established bases on the Galilean moons, we could then turn Jupiter and subsequently Saturn into the, quote, Persian Gulf of the solar system. And this would be done by scooping up hydrogen and helium-3 fuel from the atmospheres of these gas giants. And this would provide abundant fuel for the solar system, especially for fusion reactors and nuclear thermal spacecraft or fusion drives. Basically, settling the Jupiter system and then the Saturn system, this would help usher in the fusion era. And NASA has also made proposals of this nature, saying that bases in the outer solar system would be able to provide limitless fuel for fusion reactors back here on Earth or anywhere else in the solar system. And in 2012, the Lifeboat Foundation, which is a nonprofit organization that is dedicated to the preservation of humanity, according to their mission statement, they released a study titled Colonizing Jupiter's Moons, an Assessment of Our Options and Alternatives. Specifically, this report looked at establishing settlements on the Galilean moons as an alternative to lunar and Martian settlements. And the idea has even been flirted with by Elon Musk and SpaceX, in the process of proposing the Mars Colonial Transporter, which has since matured into the Interplanetary Transport System and then the Starship and Super Heavy, there was speculation that the same spacecraft could facilitate journeys to the outer solar system and even artist renderings of the Starship landing on the surface of Europa. In addition, the Jovian system contains countless smaller moons and lots of asteroids, which are a very abundant source of minerals, metals, volatile elements such as water, frozen carbon dioxide, ammonia, and methane, and silica and organic molecules. And these include the Greeks and the Trojans, two families of asteroids that follow Jupiter around in its orbit, which could be mined for substantial resources and wealth, which could be harvested as part of an in situ resource utilization program in order to build facilities and bases in the system and infrastructure throughout. And on top of that, there's just the sheer abundance of water. Ganymede in particular is believed to contain more water in its interior ocean than all the surface oceans of Earth combined. Now, of course, not all of this water is going to be accessible, especially if there's life to be found in these oceans, but not all of it has to be. The sheer amount of water means that a settlement created on any one of these moons, or in combination, would have enough water to last them almost indefinitely. And this could be used to fashion propellant, drinking water, irrigating water, and even chemically disassociated to produce oxygen gas. And, as always, this is usually where the challenges and the hazards come up. And when it comes to living on Jupiter's largest moons, not just exploring, but living and thriving there long term, the challenges are legion. And the most obvious of these is distance. Similar to Mars, the time it takes to reach Jupiter from Earth, it varies considerably depending upon when Jupiter is in opposition relative to the Sun, which is to say on the same side of the Sun as Earth. When it's at conjunction, Earth and Jupiter are on opposite sides of the Sun and will be at their farthest point apart. So basically, Jupiter will go from roughly 587 million kilometers to 967 million, and that's 365 million to 601 million miles. But unlike Mars, these windows, these oppositions, they occur every 398.9 days, so roughly a year and a month, whereas with Mars, it'll take over 2 years before a launch window presents itself. However, the transit time is still very, very long. Using conventional propulsion, it takes robotic missions between 5 and 7.5 years to reach Jupiter. So right off the bat, new methods would be needed. Something faster, something with higher specific impulse, something with greater energy density and fuel efficiency. And one possibility, which NASA has been exploring for some time, are nuclear thermal or nuclear electric rockets. And this goes back to the 1960s there with the development of the Nuclear Engine for Rocket Vehicle Application, or NERVA, which we've talked about in previous episodes. And using this type of slow fission reactor, NASA could build spacecraft equipped with Hall effect thrusters, or ion engines, which would draw electricity from the nuclear reactor to generate electromagnetic fields which ionize particles of xenon or other inert gases, which then are channeled to generate propulsion. In a nuclear thermal engine, you have hydrogen fuel being heated directly by the reactor, causing it to expand, and that too is channeled through nozzles to generate propulsion. And this would cut down on travel times significantly. But whereas in the case of Mars, a nuclear thermal, nuclear electric system, or a bimodal system that combined both could reduce transit times to roughly 45 days. However, the same system would still take 1,000 days to get to Jupiter, even when it's at its closest. So, barring even more exotic propulsion systems, a crew is going to have to be set for a long voyage. So this will mean spacecraft that can carry lots of supplies, but are also bioregenerative in terms of their life support systems and anything else that they can possibly manage in order for them to sustain the crew for these long journeys. And so there will also need to be advanced waste recycling and disposal methods and means of protecting against radiation, which is going to be considerable by the time the crew reaches Jupiter's system. And there's also the issue of microgravity in space. So that is likely to mean that a spacecraft equipped with a nuclear propulsion system is also going to need a rotating torus, a section of the ship that rotates to simulate gravity in order to ensure that the crew remains healthy for the entire duration. And that's simply the matter of getting there. Once crews are there, once human beings are attempting to set down on the surface of any of these bodies, the radiation environment is really quite hostile. Io is often immediately written off when it comes to proposals for settlement because of its extreme volcanic environment and its proximity to Jupiter, so it receives far too much radiation to be considered safe. Ganymede manages to do better than Europa because it is one of the few satellites in our system that has a magnetic field. Even so, it still receives quite a bit of radiation on the surface. Only Callisto meets the radiation requirements for astronaut health and safety. And on top of that, there's Jupiter's magnetotail, so that even Callisto, which is not subject to regular doses of high radiation, it occasionally sweeps through Jupiter's magnetotail, exposing the surface to heightened levels of radiation until it clears. So basically, any settlement orbiting Jupiter is going to need radiation protection in one form or another. There's also the matter of gravity. Now, on Jupiter's largest moons, it ranges from 12.6% of Earth normal for Callisto and 18.3% for Io. And this, of course, is related to their densities. So here, too, you have the issue of what long-term exposure can mean. Bone and muscle degeneration, psychological and cognitive impacts. So again, artificial gravity is going to need to be a solution. Luckily, there are possibilities, and they have been researched at length. And many of these were contained in actual mission proposals. For example, you have the aforementioned HOPE study conducted by NASA in 2003, which recommended a spacecraft equipped with a nuclear electric engine and a rotating torus that would be destined for Callisto on a 5-year mission. NASA performed a similar study in 2011 called Nautilus X, which was short for Non-Atmospheric Universal Transport intended for lengthy United States exploration. So here, too, the concept involved a spacecraft with a rotating torus right around its center that would not only provide simulated gravity for the astronauts as they're traveling to the system, but upon arrival, this torus could be separated and used as a space station, which settlers could occasionally retreat to for the sake of gravity therapy. And this echoed something that the Lifeboat Foundation recommended in their report, where they indicated that the Jovian moons were the most preferable destination beyond the Moon and Mars, and they recommended that pinwheel stations throughout the system would provide a long-term solution to the issue of lower gravity. In addition, there are plenty of solutions for building on the surface of the largest satellites. On Callisto, for example, it is covered in many large craters, the largest of which are Asgard and Valhalla, and they're made up of these concentric rings. And each of these concentric circles could be enclosed by a dome. Another idea is to build domes in a tube-like fashion so that they're stationed and steadied from peak to peak and maintain a livable volume within the entire valley. And inside of these, ecosystems could be engineered. And this would consist of placing a layer of regolith that are harvested from nearby asteroids and rocky bodies between the settlement and the ice sheet. That way, when you increase the temperature, you're not melting into the ice. And then this could be fertilized with water and organic molecules, locally sourced, to create soil. And then you can build on top of that. You can start paving sections to build infrastructure, and plants and animals could be imported and introduced into this to create a self-sustaining ecosystem. And this would provide long-term sources of food, but would also help replenish the water and the air. Now, as for on Europa and Ganymede, given the higher levels of radiation, studies have focused on how habitats could be built within the ice sheet. And as said before, these air pockets, they could provide natural shielding against radiation, and they wouldn't have to be particularly deep either. According to research by Rich Terrell of NASA's Jet Propulsion Laboratory, you'd only need to dig 2 meters or 6 feet into the ice in order to provide for all your radiation protection needs. And then, same thing. Settlement could be built by insulating the ground with powdered regolith, fertilizing it, turning it into soil, and then building up the infrastructure needed. And while creating a settlement on Io is really not advisable because of the chaotic nature of its surface, it is incredibly rich in terms of molten metals and volcanic gases, and if harnessed, these could be a tremendous source of power and basic elements, many of which are needed in manufacturing for the entire system. And as noted, the system is incredibly rich in terms of volatile elements, such as frozen water, frozen ammonia, frozen methane, and these could be harnessed along with minerals and metals, and they could be used to fashion everything from oxygen gas, drinking water, and chemical fertilizers to propellants. And last but not least, Jupiter's powerful gravity and its magnetic field, which is one of the leading hazards in the system, they could be harnessed to generate tremendous amounts of power. So, as noted, Io, Europa, and Ganymede all experience tidal flexing in their interior because of Jupiter's powerful gravity, and this leads to, in the case of Io, powerful lava flows, and Europa and Ganymede, it's believed to cause hydrothermal activity at the core mantle boundary. So if turbines were placed around these hydrothermal vents, they could spin wheels and generate electricity, as well as absorbing heat and chemical energy coming from the interior. In the case of Io, you'd need to get pretty creative, but again, super materials or something that can just turn that immense amount of heat and lava into an electrical source. There are means. That too could turn Io into a massive power station. And even more radical is the idea of putting piezoelectric devices inside the moons to convert that tidal flexing into electricity. And that's something that would require access to the core regions of these moons, so that would be a far-off possibility, but it is a sustainable and renewable one. So it's definitely something worth considering. And slightly less exotic, there's the idea of placing satellites with powerful electromagnets in space, and as they pass through Jupiter's magnetic field, they will extract energy. Similar to how space-based solar satellites could collect power 24/7 from the sun and beam it to Earth, these would be able to extract energy from Jupiter's magnetic field and beam it directly into habitats on Jupiter's moons. Now, lastly, but perhaps most importantly of all, there's the question of what if we find life inside of Europa, inside of Ganymede, inside of Callisto even. And so we have to then ask the question, what happens if these moons already have indigenous life on them and we intend to settle? This not only creates a huge opportunity for immense scientific research that could provide extreme insight into how life originated in our solar system and where else it could be, but it creates a massive ethical burden. If we are going to settle on these moons, much in the same way if we're going to settle on Mars or in the clouds above Venus, should they also be home to life forms, most likely simple bacterial ones, what is our presence going to do? What's the impact going to be? And so planetary protections, we're going to have to work that out well in advance. If we intend to study life there, we need to do so in a way that is as non-invasive as possible and as careful and sterile as possible. And if we're going to build settlements and build infrastructure and tap the system for energy resources, we need to know where the life resides, where it's most likely to be found. And of course, we need to ensure that we can go about development in a way that's sustainable so that we're not causing a massive ecological disaster. So we're not just talking about human safety and health and well-being. All those considerations need to be worked out well in advance, but so do the ethical and planetary protection considerations. If we intend to send human missions anywhere in the solar system, we need to know exactly what impact that's likely to have. So as a final point, I'd like to ask the question that always comes up in these situations, is it worth it? When it comes to the benefits and cost analysis, what exactly are we gaining by establishing a human foothold in the Jupiter system? Well, for starters, as Robert Zubrin argues in his seminal book, Entering Space, establishing settlements in the Jupiter system, on its largest moons, in space around the massive gas giant, it could provide tremendous resources, especially in the form of helium-3 and minerals. This would allow for another major step towards a post-scarcity economy, the elimination of wealth and poverty for our species. The potential for scientific research is also incredible. We would be able to study Jupiter and learn about the dynamics of gas giants, its powerful magnetic field, its incredibly turbulent atmosphere, and the evolution of the solar system. We would have the chance to study life beyond Earth, should it exist. And we can do so safely, provided we take the necessary steps and make sure that we've got all the right ethical and protection laws in place to begin with. And of course, there's the possibility of refueling stations and outposts in the system, which would allow for missions farther into the outer solar system, particularly to Saturn, which is also a major system when it comes to an abundance of resources. And so, as Robert Zubrin summarized, the outer solar system could become the Persian Gulf of the solar system, but it would be providing for a fusion economy, not a fossil fuel economy. So the potential, much like the risks, are rather incredible. And above all, there's just the potential for adventure. You propose the idea of going to Mars or going to the outer solar system and staying there, of creating a life, of building with the local environment, studying from it, learning from it, and seeing a new branch of humanity being created. The idea just inspires a lot of awe, wonder, and excitement for many people. And so it's a safe bet that if someday the option exists, if we have reached out and already placed humans in significant numbers on the moon, on Mars, in the asteroid belt, in the clouds above Venus, then there are those who are going to look even further and who are going to say, let's get out to Jupiter. Let's see what's there. Let's establish a home there. And hopefully, because living in these environments requires living sustainably, that will ensure that we don't wreck the place up and cause ecological collapse. One of the main reasons that settling space is so very attractive is that it will help ease the burden we've placed on Earth, and also foster technologies that could help save this planet. As the saying goes, with every mistake, hopefully we are learning. Well, thank you for listening, and tune in next time where we will discuss how human beings might settle on the largest moons of Saturn, and within the Saturn system, the benefits, the challenges, and the potential of finding life there too. We'll also get into more proposed resolutions to the Fermi paradox, and we'll get the chance to speak to some other exciting guests who are established veterans of the space industry and space exploration, or rising stars, people who are working towards making great breakthroughs. In the meantime, thank you for listening. I'm Matt Williams, and this has been Stories from Space.
We hope you enjoyed this episode of Stories from Space podcast with Matthew Williams. If you learned something new and this podcast made you think, then share itspmagazine.com with your friends, family, and colleagues. If you represent a company and wish to associate your brand with our conversations, sponsor one or more of our podcast channels. We hope you will come back for more stories and follow us on our journey. You can always find us at the intersection of technology, cybersecurity, and society.